Hello everyone, my name is Tarun. Today I'm excited to share you with my project on malware analysis tool. As someone who is passionate about cybersecurity, I have invested more time on researching and analyzing the fileless malware. So today by the end of the presentation, I hope that you will get a better understanding of the importance of fileless malware and the role of my tool that can detect the fileless malware. The problem statement is to develop a malware analysis tool that can detect and analyze the fileless malware. The solution will be of desktop application. Abstract. Fileless malware do not use traditional executables to carry out its activities. So it does not use the file system, thereby evading signature-based detection system like antivirus or sandbox environments. To analyze such malware, security professionals use forensic tools to trace the attacker, whereas the attacker might use anti-forensic tools to erase the traces. Introduction. The motivation behind our malware analysis tool project could be to address the growing threat of malware in the digital world. Malware is becoming more sophisticated and can cause significant damage to computer systems, networks, resulting in financial losses. The tools and technologies we are going to implement in our project. PyQt. We use PyQt to create a user-friendly interface that allows user to interact with our tool and analyze malware samples easily. FTK Imager. We use FTK Imager to capture the memory dump of the system. Volatility. Volatility. Volatility is the main tool of our project. Volatility is used to extract features and analyze the memory dump of a system that has been infected by the malware. Volatility provides a wide range of plugins like PS-Tree, PS-List to extract the features. Machine learning. We build a machine learning model from an existing dataset that contains attributes like PS-List, DLL-List, Malfind, PSXView, etc. PyInstaller. We use PyInstaller to package our malware analysis tool into a standalone executable file that can be run on different operating systems. This can make it easier for users to use our tool without having to install Python or any additional dependencies. AWS. We use AWS S3 bucket to store the user input and run the virtual machine on EC2 instance to analyze the memory dump. Methodology. Our tool initially takes memory dump as input. If the user does not have memory dump, we pack FTK imager with our tool to have the privilege for the user to take the memory dump. We have an option as capture memory. If the user clicks on the capture memory, we automatically send the memory dump to the AWS S3 bucket. Then we use AWS Kali virtual machine on the EC2 instance to analyze and extract the features from the memory dump using volatility 3. Analyzing and extracting features will be automated using Lambda service, which is provided by the AWS. We have a Python code that uses volatility 3 and extract features using some plugins and output the information into a CSV file. We build a machine learning model from an existing dataset and test the model with our output information. If the model finds that extracted features are malicious, then our tool alerts that their memory is infected. This is the flowchart of our project. Initially, user gives the input as memory dump. The memory dump gets stored in AWS S3 bucket. We access the memory dump from S3 bucket using AWS configure. We use volatility 3 to extract the features from memory dump using a Python script. We make a test data from the extracted features, then give the test data to a machine learning model. This is how our machine learning model gets trained. We have a data set. We split the data set into train data and test data. We implement random forest algorithm and train the random forest algorithm using train data. Then we compare the ypred and ytest variables and get the accuracy. By doing that, we got an accuracy of 1. By that, we can say that our model is ready to predict. Then we give the test data to our model. Then it predicts whether the user gave the malicious or the benign memory dump. This is the feature extractor code which is in Python. Initially we have an empty list. Then we use PS list, DLL list, handles.txt, LDR modules.txt, modules. All these plugins are used to extract the individual features of the different plugins, and all these features are appended into a list. We give this list into our machine learning model, which looks like this. Initially, we read the dataset, then we implement our random forest algorithm on our dataset, then we give the output features as an array, then we predict that, then we classify as 0 and 1. 0 means it is benign and 1 means it is malware. So I have manually analyzed and got an output of 0, that is the memory dump which have analyzed and extracted features. The memory dump is benign, that means no malware. So in conclusion, we are going to develop a tool that uses Volatility 3 framework to extract various features from memory dumps. Our tool can analyze memory dumps from Windows systems and extract a wide range of information such as running process and network connections. We believe that this tool will be useful to the individuals to check whether the system is infected with the fileless malware or not. We plan to continue developing this tool and adding new features in the future. Thank you.